Hello and welcome to another Portworx demo. In this demo, we look at how you can deploy Amazon EKS Anywhere clusters on your VMware vSphere environments inside your own data center and still get the same level of consistency at the storage Kubernetes storage layer that you get in AWS Cloud when you're using EKS. As part of this demo, we will log into an EKS admin machine, which is a simple Ubuntu virtual machine that's running on your VMware cluster. And then using that admin machine, we'll deploy an EKS Anywhere management cluster. And the next step after that is deploying those EKS Anywhere workload clusters. So each management cluster can have one or multiple workload clusters attached to it. All of these nodes are running Ubuntu as the base OS, but they are running the EKS distro or EKS distribution, which provides consistency at the Kubernetes layer as well. Here we are logged into the EKS admin virtual machine. And first, what we can do is check the version of EKS CTL running on the system. So EKS Anywhere clusters can be deployed using the EKS CTL Anywhere CLI utility. So we are running the version 0.7.0. And these management and workload clusters can be deployed using simple YAML files once you have met all the different prerequisites. As part of each YAML file, so this is for the management cluster, you can define things like the name of the management cluster, the different network siders that you want to use for pods and services, the count for control plane machines, worker nodes, and HCD virtual machines that you want to deploy, the version of Kubernetes that you want to run. In the second half of the YAML file, you have to link it to your vCenter environment. So you need to provide its IP address or host name, the thumbprint, and then specify the virtual machine configuration or vSphere machine configuration. So we have defined all of that in a simple YAML file, and you can just use a single EKS CTL create cluster command to deploy the EKS Anywhere management cluster. So to do that, EKS CTL Anywhere create cluster, and it will run through a bunch of different validations to make sure that you have defined the right thing. So it checks with your vCenter server, make sure it has access to it. It checks that the resource pools and data stores that you have provided are there and match the name. It checks for your VM folders that you have defined and the network that you have defined inside that YAML file. So here we have a resource folder, EKS VM, that doesn't have any virtual machines yet because we are waiting for the deployment to happen. But you'll see a few templates that are already existing in our vSphere environment. So depending on the version of Kubernetes, EKS Anywhere pulls down a new template and then loads it into your VMware environment. Once we verify that everything in the VMware environment looks good, we can wait for the management cluster to come online. And again, since this is a recorded demo, we have sped things up a bit. It usually takes around 15 minutes for the management cluster to be fully up and running, which includes the HCD deployment, the control plane worker deployment, the actual worker nodes as part of the management cluster deployment. And all of this is done after setting up like a bootstrap cluster on the admin machine and then transferring those roles to the actual management cluster when it's fully up and running. So at this point, we have a management cluster. Next step is deploying additional workload clusters for running our stateless or stateful application on Kubernetes. To do that, we'll follow a similar process. We'll use a YAML file which has our configuration for our workload cluster. So let's just log into it and make a few adjustments. So you can edit the name of the workload cluster. Again, you can choose any name you want. You can customize the network siders, the version of Kubernetes, the number of VMs that you need as part of HCD, control plane, and worker nodes. This is for the workload cluster itself. So you can specify all of those things. One good thing about EKS Anywhere is you can have different vSphere machine configs for each of these instances. So your control plane VMs can be of a different size, your HCD VMs can be of a different size, and your worker nodes can be bigger because that's where you need to run your containerized applications. So you can define all of those different parameters as part of this simple YAML file and then run it against your management cluster kube config. So let's go ahead and save our virtual machine our workload management, our workload cluster, and we'll use another EKS CTL anywhere create cluster command. But this time, instead of deploying a management cluster, we'll pass it the file for our workload cluster and provide the management cluster's kubeconfig file. So you can do that, and as part of the deployment, it will deploy a workload cluster using the management cluster that we just deployed earlier in the demo. So this follows the same process. Like, it refers to your YAML file, validates that all of the things that you have defined are accurate, and then starts deploying those virtual machines on your VMware cluster. They start with deploying etcd, followed by control plane, followed by worker nodes. You need to make sure that you have a DHCP server running in the same subnet that's able to hand out IP addresses to all of these different virtual machines that come up. But if if all the prerequisites are configured correctly, it takes another 10 minutes for the EKS Anywhere workload cluster to be fully deployed, and you have a generated kubeconfig file that you can use to start interacting with your workload cluster. So for this next step, what we'll do is we'll update our kubeconfig variable and point it to the new workload cluster kubeconfig file. So for that, we'll use a variable called export cluster name. Give it the name for a cluster, because the name of the cluster is actually used to create the directory structure inside my home directory. So once that's done, I can point to the kubeconfig file. And then once kubeconfig is set, what I can do is start using kubectl to interact with my cluster. So if we do a kubectl get nodes, you can see we have one control plane and 3 worker nodes that were deployed 2 minutes back, running version 1.21 of the EKS distribution. You can do a kubectl get pods in the kube system namespace. You will see a bunch of Cilium pods because that's the default CNI that's supported. You'll see vSphere CSI storage pods because that's what was used to deploy storage for these worker nodes. Now, let's talk about how easy it is to deploy Portworx on top of an EKS Anywhere workload cluster. To do that, we'll create a simple secret in our kube system namespace, which provides the base 64 values for our vSphere username and password. And I've just used base 64 version of administrator at vsphere.local and my password. Once that's done, you can navigate to central.portworx.com and generate a simple Portworx specification or configuration. Here you can select things like the version of Portworx you want to run, whether you want a built-in or external etcd instance. We'll select vSphere as our cloud environment, and here you can specify the IP address or host name for your vCenter endpoint and specify the prefix of the data store that you want to use for provisioning those virtual disks. Once that's done, you can leave everything else as default or change things or customize things as you need. And then all you have to do is hit finish, read through the EULA, hit agree, and you'll get a couple of simple commands. The first command is used to deploy the Portworx operator, which will then deploy the Portworx custom resource or the Portworx storage cluster. So once the Portworx operator is up and running, and this gets deployed by default in the kube system namespace, so we can just do a kubectl get pods in the kube system namespace, and we see that the container is in the creating state. It goes from container creating to running in a few seconds. And then at this point, once the operator is running, we can define or deploy the custom resource, which is a storage cluster. We have a YAML file already generated, which specifies the version of Portworx, the size of the drives that will get deployed, the vCenter endpoints, the secret that we had created. So it points to that as well. And you can just verify everything looks good. Once it does, you can just do a simple kubectl apply of that YAML file, which will deploy the Portworx storage cluster for you. As part of this deployment, since we want to automate as many things as we can, we will start deploying all the different pods, deployments, stateful sets that are needed to run Portworx, but we will also automate the provisioning and mounting operations for individual VMDK files that will be created using the data store and mounted to your virtual machines or worker node VMs. Once that's done, we'll abstract away all of those virtual disks and present a single Portworx storage cluster or a storage pool that can be leveraged by your storage or stateful applications. So as you can see, we deploy a lot of pods that are running on your system, and all of that is happening in the background while we switch to vCenter and look at the virtual machines or VMDKs that have been added to your virtual machine. So we have a 150 gig data drive, 32 gig drive for our KVDB instance, and that will be attached to, those two drives will be attached to each worker node in the EKS Anywhere workload cluster. Once those drives are successfully attached, our installation is almost done. We are just running through the final stages of instantiating a few additional pods. Once that's done, we can just Control-C out of this watch command and run just a kubectl get pods and make sure everything is up and running and the required number of containers in each pod are up and running as well. We can exec into one of the Portworx pods and look at the Portworx cluster status. So for that, we can use our pixie-cuttle storage utility that runs inside each Portworx pod. You can access it by doing opt pwx bin pixie-cuttle status. Here you can see that you have 3 worker nodes, which matches the number of worker nodes you had in your EKS Anywhere cluster. Each node is contributing 150 gigs of storage for a total storage of 450 gigs. As part of the Portworx deployment, we also create a bunch of storage classes for you to start using. You can also customize and create your own Portworx storage classes using our Portworx documentation. But that's how easy it is to deploy Portworx on an EKS Anywhere cluster.